Assalamualaikum and good morning. Today our group will present about human population English. For the task 1, we have been given DK problem as our task. Firstly, we start our task by searching data about human population English for 20 years by using the second link given by our lecturer. Next, we proceed on finding particular solution of the differential equation for DK, plotting the graph and predict future and past value from the particular solution that we obtain. Lastly, our group makes some analysis and discussion based on the question given. Moving to the next part is table of data. So the following data set shows the available data about human population increase between year 2003 until 2023. So this data was extracted from the second link in the table, which is data.worldbank, that can be accessed through Google, Chrome or other browser apps. So we take 20 years between 2003 until 2023. So from the table, you can see from 2003 until 2010, there is an increase in population, but from 2011 until 2023, there is an decrease in population.
Now I'll be presenting the graphs. We have two graphs, as you can see here. We have the original data graph and the particular solution graph. The original data is just plotted using the population as the y-axis and the years from the years 2003 till 2023 as the x-axis. As for the particular solution, we have our amount of years as our x-axis and we have our predicted population as our y-axis. It is shaped this way due to the fact that it is a natural logarithmic, natural exponent. Yes, natural exponent graph. It is shaped in that form due to the fact that it is a natural exponent graph. Now for predicting past and future values. The particular, we've already gotten the particular solution equation, and thus we will be calculating the future value by making 2010 as t equals to 0, because that is when our decay starts to occur. Hence, thus t equals to 0 for 2010, and for 2024 t would equal to 14. You know, if you go from 2024 minus by 2010, you get 14 years, so therefore t equals to 14. We'll plug that into the particular solution, and we'll get a population of 10,800,000, around 10 million or so. Now for calculating the past value, we'll just have to use t. We'll use 2010 as our anchor, as our main, what's it called? We'll use 2010 as our main, as a reference point, and you'll minus it by 6 in order for us to calculate the population in 2004. Thus, it would be t equals to -6 for 2004. If you plug that into the particular solution equation, we will be getting around 11 million. Now for predicting years, the question is, how long will it take for the population of Greece to become 12 million in the future? Now, all you have to do is you plug in 12 million into the question and you try to find t. And if we do it as shown in the slides here, we'll get 51.4 years.
Now, analysis and discussions. Number 1. Are the values calculated from the particular solution accurate with the actual value? The values calculated using the particular solution has slightly different value than the original value obtained from the data. Now, we are required to find the percentage error for the predicted years in the past and also the future. For the future, For the future value, for 2034, we get the percentage error which is 8.42%. Meanwhile, for the past value, we get the percentage error which is 2.42%. Now, number 3. If there is any difference between the actual value and the value calculated from the particular solutions, why do you think so? The possible reasons why the value may differ from each other is due to the measurement errors. The accumulations of data for that particular year may not be correctly updated, causing a slight error to occur. Secondly, this may be influenced by external factors. A lot of situations throughout the year, such as an event of natural disaster, may have manipulated the actual data to be different from the data calculated prior.
Moving on to number 4, what has affected the population growth in the past? From the year 1990 until 2010, the population of Greece has increased exponentially. This is due to increased migration from neighborhood Balkan countries like Turkey, Albania, and Bulgaria because of the increasing search for a better job opportunity. The resulting migration has led towards the improvement in economic situation for Greece, and thus, more advancement in healthcare, education, and many other aspects are made possible. This indirectly increased the fertility rates due to more affordable and comfortable lifestyles. However, the population of Greece started to decline from the year 2011 until 2023. This is due to many factors. One of it is being the economic crisis, where many decided to leave the country due to its high unemployment rates, making skilled youngsters to migrate to neighborhood Balkan countries for job opportunities. At the same time, the outbreak of COVID-19 at the end of 2019 has caused severe decline in Greece population, as the disease reduced the children and elderly population by staggering amount over the next couple of years. Number 5, what do you think might affect the population in the future? Factors that are believed to affect the population in the future is from the advancement in medical sectors. A more effective drugs can be produced to treat numerous diseases, indirectly amplify the life expectancy for individuals of all ages. In addition to that, economic factors such as frequent foreign trading and investment conducted by the current government can yield to a higher population in the future. The reason is this can lead to better infrastructure development, at the same time being able to improve the life of its citizens. This rapid urbanization can be easily seen at Greek cities like Athens and Thessaloniki, where towering skyscrapers are frequently in sight. Lastly, constant immigration from neighborhood Balkan countries can also expand Greece's current population, as these people seek jobs opportunity in this blessed country.
Lastly, we move to the last part of task 1, which is conclusion. To conclude, the human population of Greece in the past years increased between 2003 to 2010 because of migration from neighboring countries to seek job opportunities. Meanwhile, after that, the population are starting to decrease until 2024 due to several factors such as economic crisis, high unemployment rates, and outbreak of COVID-19. Particular solution being used to predict the possible past and future population value based on the given data, but the value slightly inaccurate compared to the actual data. Therefore, we calculate the percentage error to express the accuracy of measurement compared to the actual value. Then, we predict the human population in Greece to reach 12 million. It will take 51.4 years, approximately 51 years and 5 months.
Hello. Now I'll be explaining our task 2 for our maths assignment. As you can see here, we've been given our question, and we've been asked to find the root of at x between numbers of 0 and 2.5 using the Newton-Raphson method. Now, that is correct to 5 decimal places, of course. Now, what is the Newton-Raphson method? Newton-Raphson method is one of the most famous methods used by anyone to find the root at x, to find the root of any complex functions. It derives from the Taylor series expansion at the It derives from the Taylor series by taking the first two terms of the Taylor series. By taking the first two terms of the Taylor series, we'll be having this, as you can see here. As I said before, we have the first two terms of the Taylor series, and we'll take the first two terms of the Taylor series, and we'll replace fx with 0. Afterwards, we will be making x as our subject of formula, and we'll make it into the equation that is the Newton-Raphson method, and that is how you get the Newton-Raphson method's equation. Now I'll be explaining our Excel sheet. As you can see here, we have a whole column for x, another column for our function, the third column represents our first derivative of our original function, and the final one is to represent the Newton-Raphson method's equation. Now, how do we get this? First, we expanded the original equation that we've been given, make it into the equation as you can see here in the second column. Afterwards, we found the first derivative of this offset equation and placed it in the second column. Finally, we placed all the calculations. Well, we placed the two equations that we just got into the final column, which represents the Newton-Raphson method equation. As you can see here, we have placed x equals to 1.5. Now, why did we choose 1.5? We've been told to find x between the points of 0 to 2.5. Yes. So the root at x. I'm sorry. We've been told to find the root at x between the points of 0 to 2.5. So that gives us the leeway to pick a number between 0 and 2.5, and I've decided to pick 1.5 just due to the fact that it is between these two numbers. As you can see here, x represents as 1.5. It is then plugged into the solution, into the original equation, original expanded equation, which will get 14.78, negative 14.78. X is also then plugged into the first derivative of the original equation, as you can see here. And finally, with all three pieces of data, it's all plugged into the Newton-Raphson method equation. And as you can see here, it is plugged in. Finally, it is then looped until there is a pattern that is formed. Well, not a pattern, until consistent data is until we have consistent data, which is 1.01864. That would be our root. And as you can see right beside the table, we have the graph of our original expanded equation. I have placed it into decimals and taken a screenshot of it, as you can see there. It's shaped this way because it is a piecewise function. That will be all from me today, and thank you.